different way to solve for x and y here. First of all, what kind of a triangle is this example? Isosceles is right. It's our 45, 45, 90 case. What was the, if you remember from last Thursday, the, what was the relationship between the sides? 1, 1, 1 radical 2. Remember that? 1, 1, 1 radical. So the sides would be 1. Remember, that's like the reduced ratio, right? We do a little triangle, 1, 1 radical 2. And I think I even wrote a 1 there just so you knew, right? Okay. So if I go ahead and do that, and then we add what we know here, okay? 3 would be across from the 90. So I'm going to put 3 here. And I'm going to put x, and I'm going to put y. You with me so far? And it's kind of like drawing a little triangle where I have 1, 1, 1 radical 2. And this is like my scale model, and this is a similar one that's bigger. Does that kind of make sense if I say it that way? Small, similar, just a bigger one. What's a scale factor? That's really what we're looking for, isn't it? So can I write a ratio? I can write a proportion. 1 over y, or 1 over x. So 1 over x is equal to radical 2 over 3. Do you see that? Can I go ahead and solve this for x? Sure. We'll cross multiply. What do I end up doing to solve for x? I end up dividing by the square root of 2. Didn't I know I was going to have to divide by the square root of 2? For those, the way I taught you last time, if you have your hypotenuse and you're working backwards, don't you divide by the square root of 2? So you end up doing it that way if you want to do it the proportion way. Okay? Some of you, I tend to not worry about the proportions. I think it's extra work. But if you really are struggling with when do I multiply, when do I divide, if you set up your small base triangle, or your scale triangle, your scale factor triangle, and then you have your other, you can go ahead and write a proportion and solve. Okay? And that will work for you every time. What's the problem with leaving my answer as 3 divided by the square root of 2? What's wrong with that? What did we talk about last class? Can't have the radical in the denominator, which is where it is. So I have to rationalize it. What do I multiply by to rationalize? Square root of 2 over the square root of 2. And I know that I'm going to multiply fractions straight across. So the denominator, the square root of 2 times the square root of 2 is just the square root of 4, which is just plain old 2. And then the numerator is 3 square roots of 2. So that is the solution. Isn't x and y both the same? Okay. So some of us can do that without doing the proportion way. Perfect. Okay? I know I can. That's the way I like to do it. But I understand that sometimes it's confusing. When do I multiply? When do I divide? So as long as you remember 1 square root of 2, and then we can go ahead and set up what our problem is, we can use this to help us write a proportion. And that will work again every time. The same thing is going to happen with our second problem. So go ahead and erase your dry erase boards, and let's try this one. Let's decide how to solve for x and y here. Now we could use the proportion way again if you want, or you can do it the way that I taught you before, either way. Okay, so I'm going to pause the recording for a minute. I want you to try it on your own. Use your dry erase board. Try to write the problem, solve, rationalize any denominators that need to be, and I believe that you will have some of that here too. What's the short side in this 30, 60, 90 triangle? It's y. I'm going to highlight it, just like I told you to do that last class. I'm identifying the short side. Everything is in relation to the short side. The short x is going to be twice as long as y. The hypotenuse is twice as long as the short side. The problem is I don't know the short side. I have to find it. So I have to work backwards to get the short side. I have the long side. What do I do to get from the long side to the short side? Not multiply. I'm working backwards. I'm going to divide by square root of 3. If we're struggling with when to multiply and when to divide and by what, let me show you the other way. What is the relationship between a 30, 60, 90 triangle? Let's just draw a little scale model here. Well, let's try to make it actually look like a model. a little scale model where I have a 30, 60, 90 triangle. The short side is 1. Remember this? The hypotenuse is 2, and then the long leg is square root of 3. If I'm going to draw that scale model, can I set up a proportion now? If I want to solve for the short side, 1 over y equals square root of 3 over 4. Do you agree with that? Draw the scale model if it helps you. They're similar triangles. So we're going to write a proportion to set them up. The side that's across from the 30 is 1. The side that's across from the 90 is 2. And then we have the square root of 3. I'm going to go ahead and plug in what I know. Y is across from the 30, x is across from the 90, and 4 is across from the 60. If the chart helps you, great. If you just want to write your proportion based on the triangles, what corresponds to what? Perfect. So I say 1 over y is equal to, we don't want to put an x in there, so what's the other two corresponding sides that only have numbers? The square root of 3 and the 4. Which one goes on top? The square root of 3, because it's on the same triangle as the 1. So here's a proportion. I'm trying to solve for y, so I'm just going to cross multiply here. I have 4 is equal to the square root of 3 times y. Divide by the square root of 3. So y is equal to 4 divided by the square root of 3. What's the problem with leaving my answer that way? The radical's in the denominator. Good. So I have to rationalize it, which means I'm going to take 4 divided by the square root of 3 and multiply it by square root of 3 over the square root of 3. That's 1. So I'm going to multiply straight across. I have 4 radical 3 over the square root of 9, which is just 3. That's the same thing as y. 4 radical 3 over 3. This is the only group I saw that got that. Did you guys get it too? Okay, good. I just didn't have it right when I was there. You didn't have it written down, but you were close. All right. Now, how do I find x? Yeah, I take that number and I multiply it by 2. Now, if I didn't remember how to do that, could I set up a proportion also? Could I say the square root of 3 over 4 is equal to 2 over x? Sure. And you would end up doing the same thing, okay? No problem. But I'm going to go ahead and take 4 radical 3 over 3 and multiply it times 2. Because I know the hypotenuse is twice as long as the short leg. Okay. How do I take that and multiply it by 2? What do I multiply by 2? The 4, the 3, or the radical 3? Only the... It's just 8 square roots of 3. So there's your x, and there's your y. Bad day to miss. You have to know the rules.
Wait, so for the 90, 45, 45, what are the...
1, 1, radical 2. Yeah, as long as you remember this part, that's the part you need to remember, and the first part. Right? You just have to memorize those, unfortunately. 1, 1, radical 2, and then 1, 1, 2, radical 3. Just got to remember where they go. I'm kind of a fan of drawing your scale model and your original and just doing proportions. I think it's pretty good. Just writing, what corresponds to what. So what I think we should do is we're going to play a little game, okay? And the game is for M&Ms. We have candy, because I think we need sugar. I don't know about you, but I'm kind of dragging today. So what we're going to do is we're going to play whack-a-mole. Okay, I don't know if you've ever done that before. We're going to throw things at the smartboard, or at least we're going to attempt to. I'm going to pause the recording, because I know Miss Nash's class is watching this for tomorrow. Y'all don't get to play the game. Sorry. Boo-hoo. Sorry. You're going to come and do trig in a minute. So get your notes back out. We played a game. We're now going to look at trig. And you're not going to write everything down that you see because it's just too much, but I'm going to try to highlight some important parts. You should label this in your binders for your notes, Intro to Trigonometry. Today's date is the 24th. Of course, if you're in Miss Nash's class and you're watching this, it's the 25th. But we're going to talk about trig. Now, you all do need a graphing calculator. So if you don't have one, which it doesn't look like any of you guys checked one out, I'm going to pause the recording for a minute. Please go check out your calculator. I would like for you to go ahead and draw one of these triangles. Okay? So let's just draw the one on the left. Put triangle ABC into your notes. And don't worry about everything that you see there. Just draw triangle ABC. And label it ABC with respect to what letters are in. A is the right angle, B is the angle up top, etc. Intro to trigonometry. We're going to spend the rest of this unit dealing with trig. So far, we've already covered 3 out of the 4 things that we're going to have to do this unit. We've covered Pythagorean theorem, Pythagorean converse, special right triangles, and now we're doing trig. Trig takes a few days, okay? We're actually going to go back out and measure the height of the flagpole again, but this time using trig, okay? We're going to do that next week. Hopefully the weather will cooperate. Are they calling for snow next week? But not next week. Too early to decide, probably. Better. I'm taking the snowflakes down because, by the way, they're bad luck, and we're just getting rid of them. No more snowflakes. Because there's too much snow.
We don't want to be at school.
Look, I got to pause the recording. Hang on. Right. All right, back to trig. Here we go. So we have a triangle. Notice that I'm talking about angle C. So I have kind of a line drawn around angle C. So I'm going to kind of highlight angle C, okay? Because I want to look at labeling the sides of the triangle with respect to angle C, okay? There are 3 things you're going to label. The sides are either going to be a hypotenuse side, an adjacent side, or an opposite side. O, H, or A. Okay? The hypotenuse is always the same. It's always across from the right angle. So we can label this side as our H side. Do you agree? It's the hypotenuse. It's not going to change. It's always across from the right angle. But the opposite side and the adjacent side can change. It depends on what angle we're talking about. So in this case, with respect to angle C, which side is the opposite side? This one over here. Would you agree? It's across from angle C. With respect to angle C, isn't this side the adjacent side? Right? Okay. Same kind of thing. You don't have to write this part down, but if you look at the next triangle on the right-hand side, now we're going to be talking about with respect to angle B. We're going to label O, H, and A, and this is something I want you to get into the habit of doing. The hypotenuse always stays the same. But now with respect to angle B, isn't this the adjacent side? It's the side that's touching angle B. And then over here, isn't this the opposite side? So we're going to be labeling O, H, and A and talk about what it means to be adjacent, opposite, and hypotenuse. Because trig, at least right triangle trig, there's multiple kinds of trigonometry. We're only in geometry dealing with right triangle trig. There's sinusoidal, there's all kinds of different things. So next year you'll learn more about it. But for us, we're in with right triangles. There are 3 basic ratios. And here's a little pet peeve of mine. This does not stand for sin, cos, and tan. Sin is something you do and go to church and ask for forgiveness for. Okay, that's not this, okay? Sin is not that. This is sine. It is an abbreviation. It's a 3-letter abbreviation for sine. S-I-N-E is the full word, okay? It's the sine of B. So they just choose 3 letters to abbreviate. That's all. C-O-S is the cosine, and it's pronounced cosine, and that's the full spelling of it, okay? They're just choosing 3 letters to represent it. T-A-N. Now this one's confusing because we know what a tangent to a circle is. Maybe we do, maybe we don't from elementary school and middle school. We probably do. But tangent means something different with right triangles and trigonometry, okay? Tangents can be tangent lines. That's something to deal with circles, and we'll deal with that in a couple of months. But right now, the TAN that we're worried about stands for tangent. Okay? In a minute, I'm going to show you where those buttons are on your calculator because they are there. Any scientific calculator has the SIN, COS, and TAN buttons on them. Okay? But here is something that I like to, and I'm going to yell it. So if you don't, sorry. I am going to yell it. So if you don't like yelling, cover your ears. SOHCAHTOA, 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 SOHCAHTOA. Pretend like you're an Indian. SOHCAHTOA. Okay? Why am I yelling at it? Because you'll remember it if I yell at you. Okay? SOHCAHTOA. You're never going to forget that as long as you live. Okay? Thank you, Ryan. Sorry. I'm glad I warned you. Okay? What does this stand for? It is an acronym to help you remember the trig ratios. So, stands for sine is the opposite over the hypotenuse. It's a ratio, it's a fraction. The sine is the opposite over the hypotenuse. What do you think the cosine is going to be? The adjacent over the hypotenuse. And what do you think the tangent's going to be? Opposite over the adjacent. Very good. So if you can remember SOHCAHTOA, that will help you remember the relationship of the trig ratios. What is sine, what is cosine, what is tangent? Okay? SOHCAHTOA. All right, you remember. All right, good. You have a question? Good. They need to learn some trig too. Can they hear me? I don't know. They knock all the time. Come on. Yeah. Of course. So, before the test, as I'm passing it out. Sure. Not during the test. All right, so let's use it. Okay? So, label the sides to, let's start with the left-hand side. Okay? Let me do this. Here we go. Okay? So, with respect, so this is kind of like your example. Okay? So, with respect to angle F, label the three sides as opposite, adjacent, and hypotenuse. Which one's the opposite? Which one's the adjacent? Which one's the adjacent? Use the letters. G, E, E, F, G, F. G, did I say adjacent, right? Adjacent is E, F. Good. Which one's the opposite, Eliodoro? GE. Okay. Isn't like they're GE bring good things to life? I don't know. Isn't that like a commercial? No? I'm pretty sure. Huh? Isn't it? I think it's right. I think I'm right. Every time I'm in this thing where I'm singing commercials, I'm driving my 15-year-old crazy. It's kind of fun. I like it. I'm going to do it to you too. Okay, ready? So which one's the hypotenuse? Here we go. All right, now, so I labeled what I know. I'm going to change colors here. GE is 3, so I'm actually going to put the numbers there too, okay? So GE is 3, EF is 4, and GF is 5. Is 3, 4, 5 a Pythagorean triple? It is. If you're not sure, could I use the Pythagorean converse to decide if it's a right triangle or not? 3 squared plus 4 squared should equal 5 squared, right? And it does. So what I'd like us to do is I'd like us to write the ratios. Okay? So the sine of angle F. SOHCAHTOA. So OH is the ratio for sine. So which one is OH? 3 over 5. Good. So the sine of angle F is equal to 3/5. What is the cosine of angle F? So COA. So CA is AH. AH is 4 over 5. It's adjacent over hypotenuse. Good. And then the tangent would be 3 over No, not 3. Oh, yeah, 3 over 4. I'm sorry. Yes, opposite TOA. Opposite over adjacent. Good. Eventually, we will use these equations, because that's what they are. They're equations, to find the degree measures of the angles. Okay? And you can. I don't know what degree. That's not a 45, 45, 90 or a 30, 60, 90. I don't know what it is. Do you? No. But we can use trig to find it. We're going to do that next class, though, after your quiz. Okay? Today, we're just going to worry about sides. Could you do the same thing with this right triangle over here? This time it's in relation to angle G. Notice I have G. It's the sine of your angle G, the cosine of your angle G, the tangent of your angle G. So you're always taking the sine, cosine, and tangent of an angle. I don't know what that angle is here, so I'm just labeling it with a letter. Okay? So let's label O, H, and A, and then write the one more time. So we have GE is 3, so we have 3, EF, and we have 3, 4, 5 still. So we'll go back. What's the cosine going to be? 3 over 5. Here's something that's pretty darn important and guaranteed will come up on the SOL. What do you notice? Okay, denominators stay the same. Agreed? Any of them always the same? The tangent, right? Isn't the tangent 3/4, 3/4? Would you agree? Except for I disagree. The tangent's not 3/4. What's the tangent? It's 4 over 3. Because it's TOA. So TOA, O over A is 4 over 3. So the tangents, depending on what angle we're talking about in the right triangle, are going to be reciprocals of each other. Do you agree with that? One's 3/4, the other's 4/3. Okay. What do you notice about the sine and cosine? The sine of one angle is the cosine of the other. What else do you notice? The cosine of one angle is the sine of the other. And that's okay, just the way it happens. The reason it happens that way is because one's an opposite side, one's an adjacent. And don't those flip over here? That's all. It depends on what angle you're talking about. All right, so let's look at an actual example. Okay? Hang on, I'm going to flip. Dun, dun, dun. In a minute. Let's do here. All right. I'm going to pick a different example. Sorry. All right, so let's do a different example. I'm going to pick this example. I'm going to say that I know one of the angles, actually. I know that this is 30 degrees. We're not going to use special rights. We're going to try to use trig. And I happen to know that this side is 4, and I want to find this side. Could I use special rights if I wanted to? Yes, I absolutely could. Okay? What is it? If I know, knowing special rights, what is it? 4 square root of 3. So I know the answer is 4 radical 3. Okay? But let's say that on the SOL, my brain freezes and I forget. Is it radical 3, radical 2? I'm not sure. Well, here's what I do know. With respect to angle 30, what is side 4? Is it O, H, or A? It's the opposite side. Do you agree with that? Okay, so I'm going to label it with an O. What about X? Is it an O, H, or an A? An A. What trig function, sine, cosine, or tangent, relates O and A together? Tangent, so TOA, right? So here's what we would do. We would say the tangent of angle 30, because it's always the tangent of my angle. Up to this point, we just labeled it G or A or B, but I know the measure. I know it's 30 degrees. So what's the ratio on the other side of the equation going to be? 4 over x. And I need to solve this. Well, what's the tangent of 30 degrees? Well, here's where your calculators are going to come into play, okay? So here's what we need to make sure. If everyone can get your calculator and make sure that the mode is in the degree mode. So hit your mode key and make sure it's in the degree mode. If you have a little scientific calculator at home, you just have to make sure that it's also in the DEG degree mode. So hit mode. Notice mine is not in degree mode on the board. Brittany, do you mind putting those lights down one more time? I'm so sorry. It's in the radian mode. In this class, we don't talk about radians, but all a radian is a different way to measure an angle. Kind of like you can measure temperature with degrees or Celsius, like Fahrenheit and Celsius, right? You can measure temperature with different scales. You can measure angles with different scales as well, with degrees or with radians. And you'll learn more about that next year. Actually, you probably learn more about it after the SOL this year. No, I don't care about that. All I care about is the degree mode. The A plus BI is for Algebra 2, not you guys. So and here's the problem with this, folks. You ready? I have to reset the memory on all of these calculators before the SOL. And what do you think the default's going to be? Not degrees. Okay? And I am now not allowed to tell you to change your calculator into degree mode. I used to be able to do that. Now they're saying that's cheating or whatever. I don't know. So I can't tell you this. So we're going to practice every time checking to make sure it's in degree mode. Okay? So by the time the SOL comes, you'll be able to do it. All right. And it'll be second nature. Just remember to check. So it's in degree mode. Great. Let's go ahead and figure out, oh goodness, it's typing on top of there. Let's go back. There we go. Okay. Come on back. There you go. Let's go ahead and figure out what the tangent of 30 is. I bet you it's an actual number. If I hit tangent of 30 degrees, it's an actual number. Okay? The sine, cosine, and tangent are actual trig. They're called trig functions. They're functions. If you put a number in, you're going to get a number out. I'm plugging in 30, I'm going to get a number out. Think about the function machine y'all did in pre-algebra in middle school. Okay? You put something in, you get something out. That's what's happening here. So I'm plugging in a degree measure, and I'm getting an answer. Now, I'm going to go ahead and just, for giggles, write that that's about 0.577. I really never want you to round this. And I'm going to show you how to get around that in a minute, okay? But that we know that's a number. So don't write this part down, please, because I don't want you to really ever do it this way. I'm just showing you algebraically what we're doing. How do I solve that for x? By what?
Like you do 0.577 over 1.
I could do that. I could put 0.577 over 1 and cross multiply, couldn't I? Sure, that's one way to do it. Could I also multiply here by x and then divide by 0.477 or 577? So I'm going to divide by 0.577. So really, x is equal to 4 divided by that? Did it in 2 steps there? Well, rather than write 0.4577, I'd like us to leave it as the tangent of 30. So we're not really rounding anything. So isn't this the same as 4 divided by the tangent of 30? I do want you to write that. I do. So this is really how we would write it without rounding. And this is what we're going to actually type into our calculator. 4 divided by the tangent of 30. Now I like to go ahead and put it into the numerator denominator fraction thing because it helps me keep it straight. Do you know how to find that on the graphing calculator? This fraction bar thing? Because it is a fraction. If you're interested, it's just alpha y equals, and n slash d is numerator denominator. Y equals is on the top left. So alpha y equals n slash d, it just makes it a fraction, that's all. And it just makes it easier to kind of plug in, okay? So I'm going to put a 4 in the numerator and take my arrow down to the bottom, and I'm going to type in tangent of 30. That way it just looks like, to me, and I would arrow to the right to kind of get out of the fraction. It looks like my problem, doesn't it? Now, if you would rather use parentheses in the divide sign, that's okay too, if that's what you're familiar with. And then you just press enter. So the actual length of the side of triangle I'm looking for is about 6.93. I'm going to tell you about 2 decimal places, if we're rounding, is approximately what we're looking for. So 6.93. So 6.93. Now, that's rounded. What did you tell me it was exactly using special rights? 4 radical 3. Is 4 radical 3 the same thing? 4 square roots of 3? Sure is. So we know we did it right. Bonus. All right, I think we should try another one, don't you? A couple of these. Let's do a couple more. I didn't want it, I just wanted the x. But you could find it too. Let's find a hypotenuse. Okay, let's do it for you. I'm going to pick a different angle measure, not a 30 or a 60 or a 45. I'm going to pick a strange one because trig works with any angles. Let's actually make this 21 degrees. This angle up here. And I want, and I know that the one side would be 5, making up numbers. And we want to be able to find x. Before I begin, I need to label my triangle as OH and A. Okay? So 5 is the what, and I really only care about the sides that are labeled. I don't care about the extra unlabeled blank side. It doesn't matter. But what does 5 represent, OH or A? It's the adjacent side. Good. Adjacent to our given angle. What about the x? It's always the hypotenuse when it's across from the right angle. So what trig function, SOHCAHTOA, sine, cosine, or tangent, deals with A and H? The CA, which would be the, don't say cos, cosine, thank you. It's a pet peeve of mine. Okay? So we know we're dealing with the cosine. So the cosine, and what is it? What do I always take the cosine of? An angle measure, which in this case is going to be 21, equals sine, cosine, or tangent of an angle is equal to whatever the ratio is. So what's the ratio in this case? 5 over x. Snacker, you keep having us divide by x. They don't always. Sometimes x is in the numerator. The last one we'll look at, we'll make it that way. How do I solve this? What is x equal to? 5 divided by cosine of 21. So if I type it into my calculator, because it is in the degree mode, alpha y equals 5 divided by the cosine of 21, about 5.36. Okay? So we can find the lengths in right triangles. As long as we have an angle measure and one side, we can find another side. If I don't have any measures of angles at all, and I'm only dealing with sides, what am I going to use? Am I going to use trig? If I had 2 to 3 sides, I need to find a third side. What am I going to use? No, I don't know anything about angles at all. Pythagorean theorem. When do I use Pythagorean theorem? If I'm just dealing with sides. So if I'm dealing with a mixture of angles and sides, I'm going to use trig, unless it's a special angle, like a 30, a 60, or a 45. Okay? All right, let's try one more. It's going to be a word problem. Come on. Oh, really? It's really not that bad. Okay, let's do a word problem. All right, so let's say that, trying to think of one that would work. All right, I'm going skiing in a couple weeks, not this weekend, but next weekend. So let's say that we're on a ski slope. Oh, I'm scared. I might come back in a body cast. All right? So we're going to have Mrs. Mackert is on a ski slope that has an angle of elevation, and we'll talk more about what that means in a minute, our next class, but we'll say 10 degrees. That simply just means that this angle here is 10 degrees. Elevate from the ground up, okay? But we'll talk more about that next time. If the height of the mountain no, let's do this. Find the height of the mountain if she travels. How long is a ski slope usually? A mile, probably. No, you think it's a mile long? Sometimes they go like this. Let's say I'm going straight down, like I'm like a dummy, and I just like lose my mind, and I just ski straight to the bottom. There's no curves, there's no nothing. I'm just skiing. You ever see people like that? I was skiing with last year, and this little tiny person. I mean, I kid you not, up to here, whoosh, straight by me. It scared me to death. No, what are those things called? No poles, no nothing. Just scared me to death. Okay, so if she travels, let's say I travel, I don't know, 4,000 feet. Okay? A mile is about 5,280 feet, right? So let's say it's not quite a mile long, 4,000 feet. So let's label my picture. Find the height of the mountain. Where's X? He pointed. He's right. Okay? Yes. This is going to be X. This is your height. That's how tall the mountain is. Okay? I traveled or I skied down the mountain. I skied 4,000 feet. So what's that going to be? The hypotenuse. Good. So we need to label our O, our A, and our H. What's X? X is the opposite of the angle, because this is the angle we're talking about, right? So it's going to be the O, and the 4,000 is going to be the H. Which trig function? So, Katoa, sine. Okay, so it's the sine of my angle, so it's the sine of 10 is going to equal X over 4,000. Very good. Okay. How do I solve that for X? I know the sine of 10 is just a number I can plug into my calculator. But what do I do with that 4,000 to get X by itself? Multiply both sides by 4,000. And it cancels here. What I do to one side, I have to do to the other. So X is equal to 4,000 times the sine of 10. And you're literally just going to plug that into your calculator. 4,000 times the sine of 10 degrees. Ms. Mackett's a daredevil. How tall is this mountain? Not real tall, is it? Okay. It's the bunny slope. Okay, Ms. Macker didn't go very far, right? Because the mountain's not that tall. 694 feet. If I traveled 4,000 feet,
That's like 600.
600 feet from a mountain, that's like the garbage, whatever. It's like the dump. It's a hill. It's not that tall, okay? So 695, I said never round to a whole number, so what would we say? 694.6, and it would be feet, okay? So in all of these right triangle problems for now, the ones we're going to know how to do for our quiz that we have next class, is you're going to have to be able to identify what trig function, sine, cosine, or tangent, and then you're going to have to write an equation to solve. You're going to be given the angle every time for now. After the quiz, we'll talk about how do we find the angle. A little bit different. Fair enough? All right, so you guys have some problems to work on for homework. Let me give those to you now. So for next class, if you go ahead and look at the packet and open it up, if you look at the very back of the first page, it's a special right triangle review. It's good because you have it on your quiz next class, right? So you're going to do those problems. There's only a few of them. There's 10 problems there. And then on the next page, you're only going to do problems 1 through 10 on the next page as well, okay? So basically the first 20 problems total, the first 2 pages of the review. Now what else could be on my quiz? Pythagorean theorem and the converse of the Pythagorean theorem, right? So what you should be doing as a review, does anybody have their flip chart for similar triangles? Like that sheet, does anyone have that handy? You have your note, someone should. Do you have yours, Ryan? That one, yes, Jonathan, thank you. Everyone can go ahead and get out your similar triangle flip chart. Remember we added note cards to both the front and the back? If you turn it over, there is a converse of the Pythagorean theorem on it. You need to fill that out too, okay? So when is it, so for example, if it says, if blank, the triangle is blank. So in other words, if a squared plus b squared equals c squared, then the triangle is what? Right, acute, or obtuse? Right. So I want you to fill that in, okay? So you're going to have 3 of these. And what are your cases? We have a squared plus b squared is greater than c squared, and a squared plus b squared is less than c squared. So take a second, just fill that out now, this is going to be a right triangle. What's the second one? It's acute. And then the last one would be the obtuse case. So this could be on your quiz as well, okay? So keep that in the back of your mind. Pythagorean theorem, this converse, and then your homework is just the first 2 pages of your packet. A total of 20 problems. Please pay attention to the back of that very first page. A lot of you jump and skip the very first problem. It's labeled number 7 at the very, very top. Don't skip it. Okay, it doesn't start at 1, it starts at 7 at the very, very top. Don't skip that problem. Everybody automatically jumps to number 1 down here. So don't forget that problem up at the top, okay? So first 2 pages of your packet is homework. And you guys do have a quiz next class, okay? And the quiz is on sections 8.1 to 8.3 in your textbook. If you wanted extra problems to look at or study, you can look there as well. Okay? All right, you can go ahead and use the time wisely now if you want. If you're done, you can put the stuff away in the calculator, put your calculators back, that's fine too.